math hour for Math 2412. We're going to be going over conics today, parabolas, ellipses, hyperbolas. We have a good amount of examples. So from 10.2 is your parabolas, 10.3 is your ellipses, 10.4 is your hyperbolas. And then we're going to be looking at a couple of examples from later in the chapter on converting from polar to rectangular points. So the first few sections are about conics. So what are conics? A conic section, or just conic, it's the intersection of a plane. Think of a plane like a sheet of paper, right? And a double nabbed cone. So here's the examples. You have two cones touching at the tip. And if we intersect them in different ways, we get our different conics, right? So if we intersect like this, we get a circle. If we tilt it, it's an ellipse, which is more elongated. If you tilt it where the plane comes out at top or bottom, it's a parabola. Where it intersects both of those cones is a hyperbola. Right at the tip, it's a point. If it intersects both in this way, it's a line, and then you have two lines. So we're focusing more on the ellipse, parabola, and hyperbola conics today. So let's start with the parabola. What is a parabola? Parabola is a set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, which is called the focus. The focus isn't on the line, though, and the directrix is separate. The vertex right here is the midpoint between that focus and directrix, so that's important. The vertex is in the middle. The axis of the parabola is the line passing through the focus and the vertex right there. So a bunch of things going on. So let's just kind of review that real quick. So here's your here's the parabola, right? The black graph right there, and here are all your points on the parabola. So it says it's all the points that are equidistant from the directrix and the focus. So let's say I pick a point right here, this one. So if I go from this point down to that line, the directrix, and then I draw from this point a line to the focus, those values are equal. Same, here's another point, right? If I draw a line to the directrix and I draw a line to the focus, those are equidistant. So the set of all of those points that are going to be equidistant to the focus and then to the directrix, that's what makes our parabola. So that's the definition right there. So your parabola can either be opened up or down, and it'll have a vertical axis, right? Or your parabola can be opened left or right, and it's going to have a horizontal axis, okay, right here. So we have all this information that goes with either of them. So for the vertical axis right here, it's x minus h squared, so the x part is squared, equals 4p y minus k. If this p-value right here is greater than 0, that means your parabola is going to open up. If that p-value is less than 0, you see a negative out here, the parabola is going to open down. Your vertex right here from the formula is these numbers, h and k. The focus is the first coordinate matches the vertex h, but then it goes up to get the focus, so it's k plus p. The directrix here, y, is the line, y equals k minus p. The axis that goes through the vertex and the focus is x equals a number because it's a vertical axis, vertical line, x equals h. So we have all that important information. Over here, what about when it's horizontal? Well, it changes right here. The formula, it's going to be the y that's squared, y minus k squared. Okay. You still have the 4p, but now it's determining if it opens left or right. So if the p in front is positive, it's open to the right. If it's negative, it's open to the left. Your vertex is still hk, but the focus, the k value matches the vertex, and the first coordinate is h plus p. The directrix is an x equals because it's a horizontal line. Okay, the horizontal line that goes through the vertex and the focus, right? So horizontal lines are x equals. But the axis is y equals, okay? So those are the differences in the equations, okay? So if we're going to be looking at this characteristics over here, we're going to call that information 1. If we're going to be looking at the characteristics over here with the horizontal axis, we're going to call that 2, okay? Okay, let's do an example here. Finding the standard equation of a parabola. Find the standard form of the equation of the parabola with vertex 2, 1 and focus 2, 4. Okay, so the vertex is 2, 1, focus is 2, 4. Is this going to be a vertical or a horizontal parabola, 1 or 2? Well, let's see. We have the sets of information here. we notice that in ours, the H's repeat. So let me emphasize that right here. So when it's with a vertical axis right here, these H's, the first coordinate of the vertex and the focus are going to be the same. That's what we mean with the H's. Over here, let me emphasize that if it's a horizontal axis, the K's repeat. So notice that the second coordinate, the vertex K, focus K, those are going to match. So right here on ours, look at the numbers that match. You have the vertex and the focus. They're both the same. The first coordinates are 2. Okay, so the H's repeat. So this is one way to show us that this is going to be a parabola with a vertical axis. Okay, so what do we have again? The vertex is 2, 1. The focus is 2, 4. So we have our H and K from the vertex, 2, 1. We're going to have to find P. So let's look at the formula for focus. Okay, so for all of these, you're going to have a bunch of information here based on what you're given, vertex, focus, directrix. Plug in the values that you know, plug in what's given, and you're usually going to have to find what's not, right? So we had the HK from the vertex. I know the value of the focus, 2, 4. So I'm going to use the formula right here for focus. It's H comma K plus P. So that second coordinate is K plus P. So I'm going to use that to help me find the p-value. So here, K plus P is the second coordinate. My second coordinate is 4. So I'm going to set that up, K plus P equals 4. I know my K value, K is 1 from over here, from the vertex. Plug that in. Use that to solve this simple equation to get P. Subtract 1 from both sides. P is 3. Okay, so now I have that P equals 3 value. So now I'm going to plug everything into my equation over here. So I have the standard equation, x minus h squared equals 4p times y minus k. Plug in everything that I have to get the equation. Now I know my h and my k, plug that in, 2, 1. And I found that p value, 3, so plug that in, and let's simplify. 4 times 3 is 12. X minus 2, that's it. You can't simplify that. So x minus 2 squared, y minus 1 squared, and the number in front is 12. So that's your standard equation for this parabola with that vertex and the focus. Okay, let's do another one. What is the standard form of the equation of the parabola with these characteristics? The vertex is 6, 3, focus is 4, 3. Okay, so let's look at what's given. Vertex is 6, 3, focus is 4, 3. So is this going to be a vertical 1 or horizontal 2 parabola? Okay, here are the characteristics again. So let's see what's given here. Remember that in the vertical axis, the H's repeat, and the horizontal, the K's repeat. So H's, the vertex and the focus, that means the first coordinates are the same. K's, look at the vertex and the focus, that means that second coordinate is the same. And what do you notice here? I have 6, 3. I have 4, 3. So it's the K's that repeat, that second coordinate. So I have 3 and 3. So that is one way, again, to determine what kind of parabola this is. And this one's going to be with a horizontal axis. So open to the right or to the left. So again, what do I have? I have vertex, HK, right? That's my HK. I have my focus. I'm going to do it like before, use that to help me find my P. For this one, it's H plus P, which is the first coordinate. Second coordinate is K, we know. So H plus P is that first coordinate. H plus P equals 4. So I'm going to plug in what I have. I have that H, which is 6. I'm going to use that to help me solve this simple formula and get P. I subtract 6 from both sides. 4 minus 6 is -2. So my P is -2. Now I have all that I need to write my equation. So take that form of the equation right here. Y minus k squared equals 4p x minus h. Plug in everything that I've already found. I have my h, my k, my p value that I found was -2. So simplifying all that, 4 times -2 is -8. So it's y minus 3 squared equals -8 x minus 6. So again, this y minus 3, since it's the y that was squared, it's a horizontal parabola, so it's going to open to the left or to the right. Because we got a negative, right, for our p, that means that this parabola would be one that's open to the left. P is less than 0, okay? So you have those options. Even though you know at the beginning, is it a vertical or horizontal axis for the parabola? Even then, is it going to be open up or down or left or right? Okay. So find the standard form of the equation of the parabola with the given characteristics. You have a focus, 0, 0, focus at the origin, and you have the directrix, that line y equals 8. Okay, so again, can we use this to tell us what type it is. Is it form 1 or form 2? Vertical or horizontal axis? Well, directrix, this one doesn't have like the previous ones to compare. This has directrix y equals 8. And what do you notice? For this one, the directrix, that line is a y equals line. For the horizontal axis, the directrix is an x equals line. This one is directrix y equals, it matches over here characteristics for the vertical axis. So that's the form we're going to use, okay? So let's see what we have. We have focus 0, 0, directrix y equals 8. So what can I plug in? What values do I know? I know H from focus. I'm going to have to eventually find P, but let's see. I'll also have to find K, right? So let's see what else I can find. I know focus and directrix, the vertex is the midpoint between the directrix and the focus. So if I have parabola of this form, okay, looking like this, my focus, this value for my example is going to be at the origin. So here's my focus, 0, 0. My directrix would be the line, and then specifically this is y equals 8. So I'm here at 0, 0. If I go to 8, my vertex is midpoint, midway in between. So from 0 to 8, what is half of that? Half of that is 4. So that means that my vertex is going to be at 0, 4, right? So I'm at 0, 0 to get my focus. I go up 8 for the directrix. So if I just go halfway, that's 4. So 0, 4 would be my vertex. So I'm using that information to find vertex. With that, that's an H and a K. So now I have my K value for my vertex, okay? I'm going to use the equation. What else do I have? Directrix K minus P. So I know that K minus P equals 8 now because I have the Y value. So I plug in what I know. Y is 8, K minus P, K is 4. I have that value. So I'm going to use this equation to help me find P. Subtract 4 from both sides. 4 equals negative P. Divide by the negative on both sides to get positive P by itself. So P equals negative 4. So I have that value. Now I can take all this information, write the equation for my parabola here. And it's this form, x minus h squared equals 4py minus k. Plug in my h, my k, 0, 4. The p that I found was negative 4. Plug everything in and simplify. So x minus 0, I don't need to write minus 0 because anything minus 0 would just be that x. So this simplifies to x squared on the right. 4 times negative 4 is negative 16. And y minus 4 will stay y minus 4. So that is the equation here. Negative for the p means it will be looking like this, a parabola going down. All right, here's another one still working with the parabola. Find the vertex, the focus, and the directrix for this parabola. So in the previous ones, we were finding the equation. Now they're giving us an equation, and we have to find the other information, okay? What is our H and our K and our P? Because we know H and K gives us our vertex, and we use that information as well to help us find our focus and our directrix. Okay, well, what form is this? Because that'll help us know what of the equations we're going to use, right? Well, this one, if you notice, vertical axis is the x squared, like I've mentioned before. Horizontal axis is going to have the y variable squared. For this one, because it was the x that was squared, it follows this form, the vertical axis, right? X is squared, so it's the vertical. So this is the information, and these are the equations that I'm looking for to use. Here's my equation given. I'm going to rewrite it. Standard form has just the squared part on one side of the equation, and it equals the rest on the other side. So I'm just going to take all of this part, this term, and just move it over. So minus 8 on the other side. So what do I have? I know this number here is my H. This number here is my K. Opposite signs though, right? It's X minus H minus K, so it's the opposite of what you're going to see. So I see minus 1, so H is 1. I see a plus 2, so K is negative 2. So it's always the opposite of what you're going to see in the parentheses there. So again, I have my H and my K, 1, negative 2. Again, so what else? This is my general form for the equation. The number outside the parentheses is 4p. The number outside the parentheses already given is negative 8. So I know to help me find p, I can set negative 8 equal to the 4p. Same thing, that's where they match. So 4p is negative 8. Use this to solve for p, divide by 4 everywhere. Divide by 4, negative 8 divided by 4 is negative 2. So my p-value is negative 2. Okay, so remember we need to find vertex, focus, and directrix. We found vertex. So how am I going to find focus now that I have the k and the p? Focus is right here. It's the h. The second coordinate is k plus p. So let me plug that in. I have the h value already. I need the second coordinate. It's k, which is negative 2, plus p, which is negative 2. So add that. Negative 2 plus negative 2 is negative 4. That's my focus. Now, directrix, again, here's the equation I'm using. Directrix y equals k minus p. So plug in my k and my p. K is negative 2 minus a negative 2. Careful because it's double negative. It's minus, but then it's a negative p value. So that double negative becomes plus. Negative 2 plus 2 is 0. So that means that my equation here is y equals 0. Okay, and those are the values we had to find here. Vertex, focus, and directrix. Working backwards, starting with the equation, and then getting all the information that you need from the equation, knowing which values represent which variables, and going from there. Okay, how do we find the focus of a parabola? Here's the equation for a parabola, okay? This is going to be vertical axis. The x is the one that's squared, okay? However, it doesn't look like the other equations we've been looking at, the basic form for the equations and that we've been looking at. So what we're going to do to get it to look like that, we need to complete the square. So again, it's going to be of this form, vertical axis, because it is the x that is squared, okay? So we're going to write our equation. How do we write it in this form? Again, we're going to complete the square. So we're going to multiply 2. We don't want any fractions here. So everything gets multiplied by negative 2 to also cancel the negative right there. So we get negative 2y equals x squared plus 2x minus 1 when I get multiplied. Add 1 to both sides because what I want to work with is just the x's on this one side. So I have the x squared and the 2x. So I move the 1 over to the other side. To match the formula, okay, so since the squared is on the left side of the equation, the x squared, I move it over. So this just moved over. That's it. That's what happened there. Okay, so that was our setup. What does it mean to complete the square? To complete the square, you have the two terms right here. You have the squared and you have the x. We're going to add a number to help us so that this factors nicely. We're going to try to make this a perfect square trinomial, hence the term we're completing the square, so that it factors really nicely here. So the way we do that, what number do we add? We take half of this middle term, half of 2, which is 1, and then you square it, and that determines the number you add right here. So half of 2 is 1 squared is 1, but you always have to do the same to both sides. So if I added 1 there, I add 1 here. Okay, we're going to factor on the left and simplify by adding on the right. So again, we picked that number so that it factored very nicely over here. X squared plus 2x plus 1 factors to x plus 1 squared. So that's an x plus 1 times an x plus 1. Okay, that's the factorization. That's what we wanted to get. On the right, if we simplify, we have negative 2y plus 2. Okay. On the right side, just factor out a negative 2 so that it looks like this form over here. So now we have our x plus 1 squared equals negative 2 y minus 1. So now we get a lot of information. The number with x is our h, opposite sign though, so it's negative 1. Number with y, opposite sign is k. So I have my h and my k. That is my vertex. I can use that. I need to find p. So what is my p value? So remember from this form, 4p is the number in front of the parentheses here. So my 4p is equal to this negative 2. 4p equals negative 2. Solve for p by dividing by 4. Negative 2 over 4 simplifies to negative 1/2. That is my p value. So I need to find the focus. So now I can take this for the focus to find the coordinates of the focus. Focus is h for the first coordinate and k plus p for the second coordinate. Let me plug everything in. H I have. H is negative 1. K plus p, I plug in my k, which was 1, my p minus 1/2. 1 minus 1/2 is 1/2. There we go. I found the focus. Okay, continuing on, another one like the one we did, find the vertex, the focus, and directrix of this parabola. Again, vertical axis because it is the squared for the x squared, okay? But similar to when we just did, this is not in the form we've been using, so I'm going to complete the square again to write it in the form. So vertical axis, again, this is the equation that I want it to get in that form. So how do I complete the square here? We're going to move the 6y over, so add 6y to both sides. Now that I have just the x's together, I'm going to split them up here. I'm going to have to add a number on this side like before so that this easily factors. I complete the square so that I factor it. It factors to the same set of factors, so that's how we end up squaring those factors. So again, what number do I add? Well, I take half of this b term and then square it. So half of 4 is 2. 2 squared is 4. So the number that I add right here is actually 4. I've got to do the same to both sides to keep your equation balanced. So I have to add 4 to the other side. Okay. Now I'm going to factor right here. X squared plus 4x plus 4 factors to x plus 2 times x plus 2 or x plus 2 squared. On the right, we simplify 6y minus 10 plus 4. Negative 10 plus 4 is negative 6. Factor out what we can there. Factor out the 6. So I have x plus 2 squared equals 6 times y minus 1 when we pull out a 6. So this is the form that we have over here. We did it. The original equation had to be, you had to complete the square on it, and that's the equation we have now. So we can get some of the values that we need now. Here's my h and k, negative 2, 1, and that's what I use for my vertex right there, those values. I'm going to have to find p as well. And like we've been doing, the number in front of the parentheses here is 4p. That number is 6. So set it up so that 6 equals 4p or 4p equals 6. To solve for p, I divide by 4 on both sides. 6 divided by 4 is 3 over 2 when you reduce. And there's my p-value. So now that's going to help me find the focus. I already found the vertex. I need to find the focus and then the directrix. I have the formulas here that I'm going to use. My focus is h, and the second coordinate is k plus p. My h is negative 2. My k is 1, and I found p to be 3 over 2. So when I add 3 over 2 and 1, I get 5 over 2. So this gives me the coordinates for my focus, negative 2 and 5 over 2. Last thing to find for this one is the directrix. Y equals, right here, k minus p, so I have that. I know my k and I know my p, so I'm plugging that in. K is 1, p is 3 over 2, so 1 minus 3 over 2, which is negative 1/2 for my directrix. So similar as the previous one, we had to complete the square. When you have the equation in this form, we pull out the values that we need from the equation. You have your h, you have your k. We found the p-value. So for these parabolas, you're going to be using those values, h, k, and p, and those are going to help you find what you need, your vertex, your focus, your directrix. You can work backwards. If you're given the vertex, focus, directrix, you pull out the h, k, and the p, and then you plug them into the equation. So you usually have those two types of problems. You either have the equation and have to pull out the information, or you're given certain information and then you get the equation from that, okay? Okay, so moving on to the next conic that we're going to be studying is the ellipse, okay? So what is an ellipse? An ellipse is a set of all points in a plane, the sum of whose distances from two distinct fixed points are foci is constant. So one of them is a focus, but we have two of them. So the plural for focus is foci, okay? So that's what that is. So what is the ellipse? The ellipse is all the points. So all the points that make the ellipse, right? Kind of the oval shape here, right? All the points that make the ellipse, such as this one. If you draw a line to the one focus and then draw a line to the other focus, that sum is always going to be the same. So if I have another point over here and I draw a line to that focus and I draw a line to the other focus and add up those distances, they are the same. Okay, so that is the definition for the ellipse. Okay. It says the line through the foci intersects the ellipse at 2 points called the vertices, okay? So if I were to draw a line right here through these 2 foci, okay, it's going to go through, it's going to hit the vertices, okay, at the ends, okay? And that's the major axis right there. The midpoint is the center. The chord perpendicular to this is the minor axis. So the way that it's elongated, we draw that line, that's our major axis, the way that it's more widened, right? That other axis would be the minor axis, the one perpendicular to that. Okay, here's some more information. Your center is going to be our HK. From the center to either foci is going to be length C, we're going to call that. So from center to the foci is C. Over here, center to the other foci is C. From the center to the end, to the vertices, that length is going to be A. From the center up to the end of the ellipse on the minor axis, that value there is going to be B, okay? And so we have some of the formulas that we're going to use. If you take this length right here, it's B squared plus C squared. We're also going to use at the end that A squared equals B squared plus C squared. We have that information that we're going to be using for our ellipses. Okay, the standard form of the equation of the ellipse with center HK and major and minor axes of lengths 2A and 2B are here. We have these two types, the two forms for the ellipse. Okay, this one, major axis horizontal, means it is more elongated horizontally. Okay, so we have the equation for that one up here, and we have all the information right here. So it's x minus h squared over a squared, y minus k squared over b squared, and that equals 1. Our center is hk. Our vertices are h plus or minus a and k. Our foci are h plus or minus c and k. Okay, now just like previously, if you notice, these k values or the second coordinates are going to match. So if you have the vertex and you have the foci points, those second coordinates are going to match when it is with the major axis horizontal or stretched longer in the horizontal direction. Okay, what about this one over here? This one is stretched more vertically. It's elongated vertically, right? The equation is looks the same, but the A and the B are switched. So the A is going to be the bigger number. So if you see the bigger number under the y squared, then that's when you know the major axis is vertical. Over here, the bigger number is going to be under the x squared, and that's when you know the major axis is horizontal or the ellipse is stretched more horizontally, okay? So center is still HK. Here, the vertice, the first coordinate of the vertex and the foci are the same. The H's are the same, okay? And we find the vertices K plus or minus A. The foci is K plus or minus the C value. So again, looking at those points, the H's repeat. So that's one way we can tell that we were going to use this formulas over here for the ellipse. Okay, so 1 or 2. 1 will be major axis horizontal, 2 major axis vertical. The other equation that we're going to use here helps us with the foci. So it says the foci lie on the major axis, C units from the center. So I talked about that before. So this is another formula that we're going to use to bring together our A, B, and C values. Okay, so here are the foci, right? Here's our center. If we go out to either foci, that distance right there is C. So this formula, C squared equals A squared minus B squared, is going to help us with the values. So from the center to the foci is C. From the center to the vertice is A. And then opposite, perpendicular to that, from the center up, hitting that point on the ellipse is going to be my B value. Same thing over here, though, but your foci are elongated in the other direction. Drawing a line through the foci, that major axis is now a vertical line, okay? But the relationship's still the same. From the center to that foci is C. From the center all the way down, this value is A. My vertices are now going to be up and down. And then from my center to the minor axis, to the endpoints left or right, that's your B value, okay? And the whole length would be 2B, right? Because from the center to one end is B, from the center to the other end is B, so you add them up, it's 2B. So again, that's important. If the length of the major axis is 2A, the length of the minor axis is 2B, and we have this relationship, this equation to help us with those, okay? Another thing we look at is the eccentricity of the ellipse. measurement of like the elongation of it, right? The relationship there is the eccentricity equals the C value over the A value. That's all we need to do for the eccentricity is know those values. Okay, so find the standard form of the equation of the ellipse with these given characteristics. We have the foci at plus or minus 4 and 0, and we have the major axis that is 10. We're going to have to find HK, AB, and C for this one, for our ellipses, okay? Well, which one is it? Is it 1 horizontal or 2 the vertical? Okay, here is the information. 1 horizontal, x minus h squared, y minus k squared. The bigger number is the A under the x squared. 2, if the major axis is vertical, x minus h squared, y minus k squared. But the bigger value A will be under the y. Okay, remember also for this one, the k's repeat, the second coordinates for the vertex and foci repeat. Over here, the h's repeat, the first coordinates for the vertex and foci repeat. Okay, here's our foci. We have negative 4 and 4, and then 0, 0. So what do you notice? The k's repeat, okay? So we have major axis horizontal. These are the equations we're going to use, okay? So foci is h plus or minus c, and k, the second coordinate is k, so we know that we found k. Okay, we know that value. The center is the midpoint of the foci. So I know the two foci. Let me try to find the middle of the foci. Well, if you can recall the midpoint of 2 points, you just add up the coordinates and divide by 2. So here, if I add up the x coordinates, negative 4 plus 4, I get 0 divided by 2 is still 0. Add up the y coordinates, 0 plus 0 is 0 divided by 2. 0 divided by 2 is also 0. So we found our center and we know our HK. So now I know the H, I had the K from before. Major axis is length 10. So remember the information, we have our major axis, right? It's going to be equal to 2A. So I can use that. So 10 is equal to 2A. Help me to find A, divide by 2. So I get that A equals 5 because 10 divided by 2 is 5. I have my A value. Okay. So the foci is going to help me to find the other value. Okay. So look at my foci, negative 4, 0, 4, 0. So the first coordinate is H plus or minus C and K. So I'm going to plug in the values. So H plus C, the first coordinate is 4. I know H is 0. I'm going to use it to find C. So 0 plus C is 4. So C equals 4. So I use that formula to help me find that value. Okay, so now I'm going to use this formula over here. I have my C value. I already have my A value. I'm going to go ahead and solve to find my B value. So I rearrange it first so that I can solve for B. So if I add B squared to both sides, but then move the C squared, B squared equals A squared minus C squared. Plug in the values that I have the A, which is 5, and the C, which is 4. So 5 squared is 25 minus 4 squared, which is 16. 25 minus 16 is 9. Square root is 3, so I found my B, which is 3. So all of this information, H and K, A, B, C, is going to help me now find the equation for my ellipse. So here's the form for my equation. Plug in everything that I have now. I have my H and my K, which were 0. I have the A, which is 5 squared. I have my B, which is 3, so it becomes 3 squared on the bottom. And it equals 1. So simplify when it's 0, x minus 0 is just x, so that just stays x squared. Same for y. Y minus 0 is just y, so I have y squared. On the bottom, 5 squared is 25, and 3 squared is 9. It all equals to 1. So for this one, I found the equation for the ellipse. I found my HKABC values using the formulas, plugging values in where I could. And then get the equation at the end, okay? Okay, we're going to find the standard form of the equation of the ellipse again with the characteristics given and center at the origin. So everything here now comes from the picture, okay? Center is right here at the origin. So we're going to work it the same. We're going to find our H and our K, and we just need the A and the B, okay? Our major axis is vertical because we can see by the picture it is stretched more in the vertical direction. So number 2, this is all the information that we're going to need. We have the basic form for our equation. We have how to get our center, our vertices, and our foci. Okay. So, well, what do we know? We're going to have to fill these values in. What do we know? It says center is at origin, and you can see from the picture, here it is. So it is 0, 0. So that is my H and K. We got that one, okay? Major axis is vertical. So we know that this is the longer axis right here. So from the center up, that's 5, so that we know that's the A value. A is going to be 5. Now we can look at it going the other direction to find our B value. Here's the center. When I go out, I go 2 spaces out to hit that point. So that means my B value is 2. I have that value. So I was able at this time to get the information from the graph, major axis information. So I got my A, I got my B from the minor axis, and then it was given that the center is in the middle at the origin. Okay, so just like before, plug all the values into the equation. H and K are 0 and 0. B is 2, A is 5, so we square that on the bottom. Simplifying, x minus 0 is just going to be x, or x squared. Y minus 0 is y squared. All over 4, all over 25 equals 1. So that is our equation for that one, for this graph right here. Another ellipse, sketch the ellipse, identify the center and vertices. All right, so we have our equation. However, it is not in the form we're used to seeing. So we're going to work to getting it in the form that we're used to seeing. It has to equal 1. So I have an x squared and a y squared, but it's equal to 36. So that's why my first step is to divide by the 36, because I need it to equal 1 for my equation, right? So there we go. I have it. And we need to reduce. So 4 over 36 reduces to 1 over 9. But we write that squared so we can see our A and B values in the bottom. Same thing, that's why 36 on the bottom is 6 squared, so we write it like that. So now we have a form of the equation that we're more used to seeing. Is this a vertical or a horizontal ellipse? Let's see. Based on the fact that we have the bigger number under the y squared, okay, the y squared has the bigger number. So that becomes the A. So this one is going to be major axis vertical. So this is the information right here that I used for that one. Okay. So I can write it in this form. Because it was just an x squared and a y squared, that means that my h and k must have been 0. So if you want to write that in to kind of see that, where the h and k come from, over 3 squared and 6 squared. So let me plug in my values. I have h and k. A is the square root of this number, so we have it as 6 squared, so A is 6. B is going to be our 3. And we can take this information to help us graph it. So center HK, 0, 0. We have vertices, H and K plus or minus A. So plug in our values here. H is 0, K is 0. So we're going to do plus A and minus A. So minus 6 and plus 6 to get our two vertex values. So it's 0, negative 6, 0, 6. And with that, we can go ahead and graph. So here's my graph. I started at center, 0, 0. My vertices are at 0, negative 6, and 0, 6. So those go along the major axis. So from here, 0, negative 6, and 0, 6, up and down, I get those values. And then I can use my B value. So I know that I'm going to go 3 to the right and 3 to the left on the minor axis to get those points. So I went 3 and 3. And that I was able to get and sketch my ellipse, okay? Okay, another one, find the standard form of the equation of the ellipse with these characteristics. They're giving you the two vertices, and the minor axis is length 2. So if we can find the h and the k and the a and b, we can find the equation here, okay? Is it 1 horizontal or 2 vertical? Let's see. They give us the two vertices, and what do you know? What do they have in common? The first coordinates, the h's. The h's repeat, so you have the 2 and the 2. So that's what tells us that this is going to be major axis vertical right here. You have the V and the F, the vertices and foci, both have the first coordinate of H. So that's what we use here. Okay, so we have H is 2. We're going to help find the other values, and we're going to do that by looking at some of the other characteristics. So what do we know? The center is the midpoint of those vertices. So like we've done before, we have the 2 vertices, right? Midpoint. So you add the coordinates up and divide by 2. So I add my x's. 2 and 2 is 4. Divided by 2 is 2. Add my y's. 1 and 11 is 12. Divided by 2 is 6. So I found the center. When you're given the 2 vertices or the 2 foci like before, the center is in between them. So you just take the midpoint and you get the center. So given these 2 coordinates, I found the center, 2, 6. Which is H and K, 2, 6. Okay, what else? It tells me that the minor axis is length 2. Minor axis is equal to 2b. So this is going to help me find my b value. 2 equals 2b. Divide by 2 on both sides. B equals 1. Okay, so what's next? I need now to use my vertices here, the formula right here. It's going to help me find my A. So I have the H, they're the same, right? The 2. Now I have K plus A and K minus A, and those are equal to the second coordinates, 1 and 11. Okay, so K plus A is 11. Plug in the K value that I have, solve for A equals 5. So I could have used K plus A or K minus A equal to the 1 or the 11. But just one of them I needed, so that gave me the A equals 5. So now I've used all of that to find HKAB, and that is what I need to plug into my formula to get the formula, right? So plug it all in. H is 2, K is 6, all over. The A value right here, 5 squared, the B value 1 squared. That I just noticed that. That's a typo right there. The 2, it should have been a B. Simplify, and what do we get? X minus 2 squared. 1 squared is 1, so over 1. Over here, y minus 6 squared over 5 squared is 25 equals 1. So this is the equation for the standard form of the ellipse, given all of these characteristics. Again, you get what you are given. You find if it's going to be the equations 1 or 2. Once we did that, we were able to get the information, plug in what we needed to, and then we get the equation of the ellipse. Okay, so now on this one, we have the equation. We want to find the center, the vertices, the foci, and the eccentricity. So we're going to pull out the H, the K, the A, the B, the C to get everything that we need for this one. Okay, is this form 1 or form 2? What do you think? Well, the bigger number is A. So we have the larger number 25 under the y squared. So it matches this form right here, major axis vertical. So that's the one I'm going to use. So what values can I plug in? Because of the way it's written right here with X and Y, we have our H and K. So H is -2, Y is 3. This is the A value. Well, this is going to give us the A value because this is A squared. This is the bigger value. So square root of that is 5. That's how I get that. 16, that's the B squared. So square root of that is my B value. That's how I get that. So the equation gave me a lot of what I needed, my H and my K, my A and my B from the denominators. So I just need to find my C value. That C value is going to help with the eccentricity. So C squared equals A squared minus B squared. C squared equals 25 minus 16. C squared is 9. Square root of that is 3. So I have my 3 for C. Now, I can use all of these values to find what I need, my center, my vertices, my foci, and eccentricity. I have it all here. So remember your center is HK. Plug in the H and the K, -2, 3. My vertices are H and then K plus or minus A. So I have the H is -2, K is 3, A is 5, so I'm going to plus 3 and 5 and then subtract 3 minus 5 to get the 2 vertices. So -2 and 3 minus 5, 3 minus 5 is -2. So one vertex is -2, -2. The other one comes from negative 2, comma 3 plus 5. 3 plus 5 is 8, negative 2 and 8. My foci are H, comma, K plus or minus C. So I have negative 2 for H. K is 3, C is 3, so I'm going to plus and then minus 3. So negative 2, 3 minus 3, and negative 2, 3 plus 3. So what does that give me? Negative 2. 3 minus 3 is 0, so that's one focus point. Negative 2 and 3 plus 3. 3 plus 3 is 6. That's my other focus point. So those are the values that we needed for those. Lastly is eccentricity. That is C over A. Now, eccentricity isn't on here. It was given separately. All the other things we found, the center, the vertex, and the foci were all given from this information here, okay? Eccentricity, however, is C over A. Plug in the C, which is 3 over A, and reduce if possible. This one doesn't reduce, so it's just 3 over 5 for the eccentricity. Okay, sketching an ellipse, another example. We're going to find the center vertices and foci of this ellipse and then sketch it. Well, if you notice, it is not in the form we're used to, so we're going to complete the square again on this one. Find out which ellipse is present after we complete the square. It's going to help us with that. Okay, here's the equation given. I'm going to separate, put the x terms together and then the y terms. So here are my x terms, x squared and 6x. I put my y terms together and I move the constant to the other side. I factored out what I could right here. So from the y's, I factored out a 4. And now I'm going to go ahead and complete the square on the x's and the y's. So for the x's, I have x squared plus 6x. I need to write the third term here so that I have a trinomial that's going to factor. And I'm going to do it with the y's too. I have 2 terms here. I need to add the third term that's going to allow me to factor this one, and it'll factor to the same 2 sets of factors, so it'll be that factor squared. And then to compensate, we're going to have to add the numbers over here to the other side of the equation. So how do we do that? So we take half of this term b and square it. Half of 6 is 3, squared is 9. So I get that number, but I have to add 9 on the other side. And then here we take half of this 2, which is 1, and square it, which is 1. But I did add 1, but it's within the parentheses. So it's really times this number 4 that's outside the parentheses. So 4 times 1. So yes, it's a plus 1 in the parentheses, but the value in this side of the equation is 4 because it's 4 times that 1. So I need to add a 4 to the other side. Let's simplify. So we factor. So these are now perfect square trinomials. So x squared plus 6x plus 9 factors to x plus 3 times x plus 3 or x plus 3 squared. Y squared minus 2y plus 1 factors to y minus 1 squared, and there's a 4 on the outside, equals negative 99 cancel, plus 4 equals 4. Now I need it to equal 1, so I have to divide by 4 everywhere. So I have x plus 3 squared divided by 4. When I divide this by 4, my 4s are going to cancel right now. And then 4 divided by 4 is 1. So again, simplifying, the 4s cancel. We get x plus 3 squared over 4 plus y minus 1 squared over 1 equals 1. Okay, so now which form is it? Well, the bigger number was under the x's. Okay, the largest number of the denominator is the a. So that determined that it's going to be major axis horizontal. Okay, oops. And then we just had to get all the information. So we're going to continue that on the next slide. So we found the equation, the type of equation. We're going to continue finding the center, the vertices, and the foci. So continuing on, we have the equation now, right? Using the one we found by completing the square. We have the information we need. So let's pull everything out. What is my h? Negative 3. What is my k? 1. What is my a? It's the square root of this number. So square root of 4 is 2. B is the square root of this number, 1. Now I need to find C. H, K, and AB you can find from the equation if you have the equation in this form. C you find by using A and B in the equation. C squared is 2 squared minus the 1 squared. 4 minus 1 is 3. Take the square root to get C. Square root of 3 is square root of 3, and that is my C value. Now, all of these are going to help me find what I need, my center, my vertices, and my foci. So right here, center is the H and the K. So you plug that in. HK, negative 3, 1. My vertices are H plus or minus A and K. So let me set that up. H plus or minus A and K. So negative 3 minus 2 gets negative 5 and 1. But then I do negative 3 plus 2, which gives me a negative 1 and 1. Those are my vertices. Foci, H plus or minus the C value, and then K. I have my H plus or minus that C value, and then K. So if you want to split it, negative 3 minus square root of 3, and we can leave it like that. You don't have to get the value of the square root of 3. Just leave it. Don't have to get the decimal value. So it's negative 3 plus square root of 3, negative 3 minus square root of 3. So we found the center. We used our formula to find the vertices, and then we used our formula to find the foci. First, we had to get this equation into our standard form so that we can see the values more clearly, and we did that by completing the square. Here is all the information because then we had to sketch it, right? Sketch the ellipse. So we mark the center, negative 3, 1. The vertices are at negative 5, 1 and negative 1, 1. So from here, we went to the left and to the right, got those points, okay? We can use the B value, go up and down 1 and 1, okay, to find the endpoints of the minor axis, right? And then we can draw that ellipse, labeling the foci there as well, okay, those coordinates. Okay, let's move on to the hyperbola. Have a quick example for the hyperbola. So what is the hyperbola? Remember, if we have the two cones touching each other at the tip, the hyperbola comes from a plane intersecting both of those cones. So you're going to have, they're separated. So you're going to have two branches, what they're called, right? So hyperbola is a set of all points in a plane for which the absolute values of the difference of the distances from the two distinct points called foci is constant. So I don't know if you remember the ellipse we just did. The distance from any point on the ellipse to the two foci, you add them up, was constant. This time, if you subtract the distance from a point on our hyperbola to the two foci, you subtract them and take their absolute value, which means you make it positive all the time. That is constant, okay? So the graph of the hyperbola has two disconnected parts called the branches. The line through the foci intersects the hyperbola at 2 points called the vertices. So the vertices are right here at either end of the hyperbola. The line segment connecting the vertices is the transverse axis, and its midpoint is the center right here. So you see the information, okay? So the center is also our HK. Our vertices are H plus or minus A and K, and our foci are H plus or minus C and K for this hyperbola. Okay, so same with the hyperbola, we can have our branches opening up left and right, or we can have our branches opening up and down. We have the equation here. When the branches are open left and right, the transverse axis is horizontal. It connects our center and our points here with a horizontal line, and here we have our equation. When our hyperbolas are open up and down, the transverse axis is vertical, and it connects all the points with a vertical line, and you have your equation here. In this form, the y is first, and then it's a subtraction of the x term. Over here, the x is first, and you subtract the y. A squared is always under the first one, whether it's the x squared or whether it's the y squared. The a squared is under the first term that you see. So here's the information we're going to pull when the transverse axis is horizontal for your center, your vertices, and your foci. And these also have asymptotes. You have an equation here for the asymptotes. When the transverse axis is vertical, here's how we obtain the information. HK for the center is the same. Notice here that the H's match for the vertex and the foci. And then it's K plus or minus A and K plus or minus C. You have the equation for the asymptotes as well. So again, on this, when the transverse axis is horizontal, the K's are going to be the same. When the transverse axis is vertical, the first coordinates or the H's are going to be the same. 1 2. Okay. Additionally, we will use the formula for c. C squared equals a squared plus b squared. Okay, let's do a example for a hyperbola. It says find the standard form of the equation of the hyperbola with the vertices 0, 2, and 4, 2. Foci are negative 1, 2, and 5, 2. Okay, pull out the information. The vertices, foci, is this version 1 or 2? Well, I see already that my second coordinates repeat. 2, 2, right? So because the k's repeat is this one. Transverse axis horizontal. This is the information I use. This is the equation I need, right? Let's plug in the values that we have. Okay, well, the vertices, 0, 2, 4, 2. And then we also have the foci, negative 1, 2, 5, 2. The midpoint of the foci and vertices is our center. So just like in the previous ones, we can find the center by getting the midpoint. At the x-coordinates, 0 and 4 is 4 divided by 2 is 2. 2 and 2 is also 4 divided by 2 is 2. So in between these, we have the center. We found 2, 2, so that's my h and k. What else? The vertices are h plus or minus a and k. We have 0, 2, 4, 2. So we can do h minus a is going to be 0. H plus a is going to be 4. So plugging in the h value, we're going to solve. So 2 minus a equals 0 or 2 plus a equals 4. When I solve either of these, minus 2, a equals 2. If I add a to the other side, a equals 2. So I'm using that formula there. I found my a value. Using the foci, I have h plus or minus c and k. My points are negative 1, 2, 5, 2. So I'm going to do h minus 1 is going to be the negative 1. H minus c, sorry, is negative 1. H plus c is the other coordinate 5. Either of these work. Plug in the h. My c value is 3. Over here, if I minus 2, 5 minus 2 is 3. C is 3. Over here, if I minus 2 and then divide by the negative, I also get the 3. So I use that formula for the c. Now what's left is to find my b using this formula here. I'm going to rearrange it so that b is by itself. So I move the a squared over. So c squared minus a squared gives me the b term. B squared is c squared minus a squared. I plug in the c value I found, the a value I found. 3 squared minus 2 squared, so 9 minus 4, which is 5. B squared is 5. Square root of that is square root of 5. So I was able to find all the values that I needed, h, k, a, b, c. Now I'm going to plug all of that in to get the equation. So this is the form of the equation that I need, okay, right here. Plug in the h and the k, minus 2 minus 2. Plug in my a is 2, so I have a squared, 2 squared. B is square root of 5, square root of 5 squared on the bottom, so let's clean all that up. Simplify. X minus 2 squared over 4 minus y minus 2 squared over 5 equals 1. Okay. And so that is about it. That is time. So we were able to go over examples of all the conic sections. You have your parabola we started out with. We have our ellipse. And then we have our hyperbola, which we were able to do an example on. So I didn't quite have time for switching from polar to rectangular coordinates. But always, as always, reach out to the tutoring centers or to your instructors with any other questions or issues that you guys may have on any of these topics.
Thank you, Ms. Camarillo, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on our YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill out the survey. Before we leave, I want to share with you the TVE sessions that we will have next week. We'll be back with Happy Math Hour next week, which Math 1332 will be covering the measures of central tendency, measures of dispersion, and the measures of relative position. And Math 2412 will be covering exam 4 review. And I want to remind you that today at 1 p.m. we'll also be having the student success topic. So thank you all for coming in today. If you have any questions, please feel free to use the chat box or the mic. And also have a great weekend. Thank you, everybody.